So for proof 7.1, we want to prove that the following three things are true in vector fields. That negative v plus v equals 0, i.e. that there's a left additive inverse. We want to prove that there's a left additive identity. And we also want to prove that addition commutes, i.e. that v plus w equals w plus v. So we begin with the first one. We want to prove that negative v plus v equals 0. To do that, we say that there exists a w such that negative v plus w equals 0. We know this must be true because there must exist a right additive inverse. So negative v plus w equals negative v plus w. We can add whatever we want. So we add negative v plus positive v, negative v plus positive v to both sides. Now we simply parenthesize and add differently. So we have negative v. We know that this is equal to 0 by definition. This is equal to 0 by construction. So we have negative v plus 0 plus w is equal to negative v plus 0. We know that 0 is a right additive inverse. So we have negative v plus w equals negative v plus v. So then we add and by construction, by construction this is equal to 0. So 0 equals negative v plus v. Sweet. So for the second part of this proof, we want to prove that 0 is a left additive identity, i.e. that 0 plus v equals v. So to do this, we say 0 plus v equals 0 plus v, obviously true. We expand 0 on one side. 0 plus v equals v plus negative v plus v. And we know from part 2 that a left additive inverse is also right additive inverse. So we know that negative v plus v equals 0. So 0 plus v is equal to v plus 0. Again, this is a right additive inverse, or a right additive identity. So 0 plus v equals v. So there exists a left additive identity. Third thing we want to prove is that addition commutes. We know that scalar multiplication and vector multiplication both commute. So we want to prove that addition commutes. So we begin with this, and we simply distribute differently. So we have 1 plus 1 v plus 1 plus 1 w equals v plus w plus v plus w. I dropped the 1 here because 1 is a multiplicative identity. Here we can expand again. So we get v plus v plus w equals v plus w plus v plus w. We add negative v to both sides. And since negative v is a left additive inverse, what we're left with is v plus w equals w plus v plus w. W also has a right additive inverse, so we add negative w to both sides, and what we're left with is v plus w equals w plus v, and so addition commutes.